3D printing? Yes, I have. I think it works using materials that can be easily changed to different shapes and combined together to create larger things.
Yeah, I've heard of it. I have no idea how it works. I would say nothing like 2D printing. Far away from putting ink on paper.
Okay.
I know a little about 3D printing, but I don't know much about it.
Do you know how 3D printing works?
No, I don't.
I have no idea what 3D printing is. I'm guessing it's going to project something on some surface which creates a 3D image.
I'm kind of envisioning like a Star Trek kind of thing, or maybe I haven't seen Star Trek, but you know, holographs, they can like twist it, like Iron Man can do that. Is it like that?
I know basically nothing about 3D printing. All I know of it is that it's relevant to like artificial organs and stuff like that. So I think I can
I'm not entirely sure. I mean, I know 2D printing is just basically just paper, basically. That 3D printing would be something that looks a bit more, instead of that, would maybe a little bit more like that. Okay, perhaps?
I know a little about it. I'm an art major, and I have a 3D printer at CMU, and you can, like, on the computer, you can have some sort of model, and then the printer will print it in, like, plastic or, like, whatever kind of, like, material that you have.
I guess for somebody who doesn't really know much about 3D printing, or I mean, now we went around to a lot of people who don't really know what it is.
Yeah.
How would you describe it? What is it?
Okay, so 3D printing is sometimes called additive manufacturing. So it's really about adding material to, or starting from nothing, adding more and more material to create shapes that have been designed electronically. So you basically specify a shape in an editing program purely in software, purely inside the machine. And then given a precise description of the geometry, this machine can lay down, you can think about slicing this into very thin layers, like 1/10 of a millimeter layers, and laying down material for parts for that layer that matches that shape, and then raise up a little bit, and then do that again and again and again, and you get a pretty precise approximation of the geometry that you specified inside the computer. And this basically lets you create a drawing of something. It's in 3 dimensions, not 2 dimensions, but create a drawing and push a button, and then the machine can automatically create an object which has that geometry. And 3D printing in particular allows you to do all sorts of interesting and fairly arbitrary geometry, including things that have holes in the middle and have very intricate kinds of shapes that would be very difficult to manufacture, to create through other means.
Okay.
So I would say the key thing is this sort of ability to edit something electronically, push a button, and it gets created. Now, it doesn't get created that fast. It can definitely take hours, but that's still a very powerful capability.
Yeah, it definitely is. I guess
The 3D printed flute is a research project in the MIT Media Lab. Our goal was to create a flute using 3D printing technologies, a flute that is compatible with a traditional concert flute both acoustically and ergonomically. This flute is composed from several materials. A rigid material was selected for the flute's body, a different one for the mouthpiece, and a soft material for sealing the air properly. Only springs were added manually later. This project was fabricated with the Object Connex machine, which can print multiple materials in a single build. The overall process took around 15 hours, creating 4 separate parts that then were assembled to a working instrument.
Object, setting the new standard. Smooth surfaces and fine details like you've never seen before. Because it's the smallest details that make the real design. And there's only one way to get it. The Objet Alaris 30 Desktop 3D Printer. It's professional PolyJet technology, which jets ultra-thin layers of model material at high resolution. Objet Alaris 30 is the first high-quality desktop 3D printer that prints detailed, true-to-life models, no matter how complex the geometry. With the Objet Alaris 30, ease of use is built in. Turn any CAD file into a final model with just a few clicks using Objet Studio software. Maximize your productivity with a large build tray that allows you to print large models or many small parts simultaneously, saving time and cost. Test the functionality, fit, and form of your designs. Highly accurate models mean you can confirm the size, shape, and interaction of your parts, and even insert electronic components. Ultra-thin layers of just 28 microns and high resolution of 600 by 600 dpi produce smooth, accurate, and highly detailed models. The variety of applications is almost unlimited. High precision printing enables fit and form testing. And painting the printed models is easy. The exceptionally smooth surfaces are ideal for vacuum forming. High durability and outstanding surface details make the models perfect for rapid tooling. With Objet Alaris 30, there is no need to compromise on model quality, tolerate design inaccuracies, or waste time and money on repeated print cycles. The affordable desktop 3D printer. Objet, setting the new standard for desktop 3D printing.
I would print out other 3D printers.
A sculpture of myself.
Something gadget or something like that.
Car? No. Why would I print a car? Get a new car for free. Why would I print a car? If I had a 3D printer, I would probably print, I don't know, envelopes, something like that.
Maybe in the future, designs I have for things, just to see how they play out. Maybe I think it could help with more architecture side or physics side of things and creating structures and things like that. Could probably have a lot of good applications in art.
Heart. Like a heart or like a... No, like a heart. Kind of engineering, baby. I don't know. I would make a bunch of iPhone cases and sell them to people.
Yeah, it definitely is. I guess, yeah, going into that, you know, with these powerful capabilities, I guess what personally interests you in like the 3D projects that you like to do, or something that you...
Well, I'm always interested in interactive devices, and so I'm very interested in sort of in a future world in which, you know, so we have devices like these that we all carry around, and right now this gets assembled, a bunch of parts get brought together, and there's a series of steps where this is put in and that's put in and this screw is tightened and so forth. And I'm very interested in sort of creating things to get to a future world in which something like this, or maybe major parts of it, not, it'll be a while before it's all of it, but something like this can really be completely printed, that you specify it all on the software side inside the computer, and then a very sophisticated and powerful machine that doesn't exist yet, but we're sort of headed in that direction, actually prints this whole thing. And once we can do that, that means that because this is coming completely from a software side specification, we can do very custom things. Right now, everybody has the same phone, or there aren't that many phones in the world, and millions of people have this very same phone.
Yeah.
But I'm sort of looking interactively, and I'm thinking about, well, what happens in a world where, okay, I get a phone that actually fits my hand, or that it has the capabilities that I particularly want, and it doesn't, and I don't necessarily have the other capabilities. That it's customized completely for me. And that opens up a different world, and we want to think different about product design. We want to think different about human-computer interaction when, I don't have to have a standardized device. It can be highly customized. It can be my phone, and really my phone built for me. And I think that's going to open up a bunch of interesting new possibilities in terms of what we can do with devices and people. I'm very interested in what we can do with multiple materials. That's sort of a new thing in 3D printing. Printers have become available where we can really print the new materials. So I have access to a very high-end printer which can print flexible material. And can also at the same time print stiff material, and it can actually mix between them. So I have this piece where it's flexible on this end and it's stiff on this end, and it's a gradient. It's half flexible in the middle. And this is really just a completely new kind of material to work with, because I can place, I can basically place the flexibility anywhere in the three-dimensional structure, so I can make things that fold in interesting ways. And then I'm very interested in looking at, can I build electronic circuits into the device and have it flex? So I'm starting a new project trying to look at sort of things like variable force buttons, so that I can, under program control, make the button harder or easier to press by some pneumatic actuation inside the device, for example. And if I can print conductive material, I can put capacitive touch sensing all over it. And with the flexible stuff, I can think about this in very different form factors. Again, this is really a box. It's rectangular. It's but maybe what I want is I want it to wrap around my wrist, or I really want to wear it in some other way, or I want to put it so it sits on my knee. I don't know.
So maybe you've heard about the MakerBot Replicator 2 desktop 3D printer, but you don't know how it works? It's cool. I'm Bree Pettis, CEO of MakerBot, and I'm going to walk you through the MakerBot creation process. The MakerBot Replicator 2 desktop 3D printer is the easiest, fastest, and most affordable tool for making professional quality models. If you're an engineer or an engineer at heart, you can keep a MakerBot Replicator 2 desktop 3D printer right on your desktop and produce amazing high-quality models while you work. The MakerBot creation process starts with the digital design. This can be a design that you create using any digital modeling program, or you can download one of thousands of models from our site, Thingiverse.com. Thingiverse is a community forum where people, like you, can share their digital designs. There are over 25,000 things on Thingiverse, and most of them can be made on a MakerBot Replicator 2 desktop 3D printer. And the best part? They're all free. Once you've got your digital design, the next step is to open it in MakerBot Makerware. This is the software that allows you to prepare your model to be made on your MakerBot Replicator 2. MakerBot Makerware is a brand new software tool developed right here at MakerBot. You can use MakerBot Makerware to move and scale your model and to arrange it just so on the virtual build plate. When you've got it just how you want it, just press Make It and the MakerBot Replicator 2 desktop 3D printer will begin transforming your digital 3D model into a physical 3D model. The material that the MakerBot Replicator 2 desktop 3D printer uses is a renewable bioplastic called PLA. When you tell the MakerBot Replicator 2 to make something, it begins by pulling the PLA filament that's spooled in the back up through this tube and into the extruder. The extruder heats it up and squishes it through a very small hole onto the build plate. It starts by laying down the bottom layer of your 3D model. Then the platform moves the object down a tiny bit so the extruder can lay down the second layer. The process continues for the next layer, and the next layer, and the next layer. This process can take some time because each layer can be as fine as 100 microns. When you're done, you'll have a professional quality model that doesn't require any sanding or finishing. Now you know how a MakerBot Replicator 2 desktop 3D printer works, and it's time to set your mind in motion thinking about how you're going to use yours and what you're going to make. Whether you're an engineer, an industrial designer, a researcher, or just somebody who likes to make things, the MakerBot Replicator 2 can help bring your ideas to life. You can learn more about the MakerBot Replicator 2 desktop 3D printer at makerbot.com/replicator2.
A lot of like really just like small like objects that people before would have had to like go to like a factory to get like casted or molded that they can now make for themselves. So I don't really know how that would change things. Maybe it would give factories for like, you know, you don't really have to mass produce like small things and like make inventions a little easier because you can custom build parts or replace other parts that maybe you would have to replace through a factory otherwise.
Any field, medical, technology, that help anything.
Yeah, maybe people can get something the virtual, the 3D model more easy.
Like if I want something immediately, I like say I wanted a tape, maybe something which I could use for immediate use.
I have no idea. Back when they were making, have you ever heard of the movie Jessica? No. It's the first movie in the world that had sound. Before then, everything was silent film. People would go, and then it would flip to a screen that said what they were going to do. And most people thought when the jazz singer came out, it would never amount to anything. Have you ever seen silent film? Yeah. Okay, well, they're actually kind of hard to find right now. I have no idea. There's lots of things that people said would never work, and there it is. Same thing with the internet. Everyone said that would be crazy, and now we can't seem to go a day without that.
Well, going on the medical side of it, I'm sure it would be helpful for like learning about organs and like people's bodies, and if you could like 3D print a heart in a material that would work so you can put it into your body, that would be useful.
I think our future's already so we got no hope. You know, sort of numbers. Too much rape going on. Too much rape has always been going on. Too much murder. No peace. You know, but we can't even find that within ourselves and our own families. So I guess it would give me the ability to print things in 3D, and hopefully advance technology in some way that some people would find applicable and, you know, use it. But I couldn't see a wide consumer base really using it or needing it for anything unless the technology is further to make it more out there, or to have a reason to want to print something.